Hey guys, it's Sherry and welcome back to my channel. So in my previous video, I went through chemical bonding and the different type of chemical bonds. And in today's video, I'm going to be talking about chemical reactions and the type of reactions. Now this is the third video in my Intro to Chemistry series, so please make sure you've seen the first two if you haven't already. And you can find the links to them down below in the description box. Now let's get into today's video. Firstly, chemical reactions involve the making and breaking of chemical bonds. And to recap, a chemical bond is the attraction between atoms, ions, and molecules to form chemical compounds. The three primary types of chemical bonding include ionic, covalent, and metallic bonding. If you would like to learn more about chemical bonds and the type of bonds, you can check out my previous video, which is linked down below in the description box. So in general, chemical reactions occur when the atoms of two or more substances are rearranged to form something new. Your reactants are whatever you start off with, while your products are whatever you end up with. And there are two primary types of chemical reactions, spontaneous and non-spontaneous. A spontaneous reaction is one that occurs by itself, and an example of a spontaneous reaction would be combustion. On the other hand, non-spontaneous reactions require an energy input, such as light or heat energy. An example of a non-spontaneous reaction is photosynthesis, and within this, sunlight is not one of the reactants. However, it is still essential for the reaction to take place. So now we know what a chemical reaction is. How do we know if one has occurred? Some physical indicators of chemical reactions include a change of colour, a change in temperature, the production of a gas, when a solid or precipitate is formed, and finally when sound or light is created. It's important to note, however, that these indicators alone cannot prove that a chemical reaction has occurred. For example, if you were to mix blue paint with yellow paint, you will observe a change in colour. However, the atoms have not rearranged and no new product is being created. Therefore, this is not an example of a chemical reaction. Now, some basic type of chemical reactions include combination or synthesis reactions, decomposition, single displacement or replacement, double displacement or replacement, neutralization or acid-base reactions, and finally, combustion reactions. And I'll be going through each of these in a little bit more detail. Firstly, a combination or synthesis reaction occurs when two or more substances come together to form a single product. And in this case, the reactants are always simpler than their products. The general notation for this reaction is A plus B becomes AB. An example of a synthesis reaction is carbon dioxide. So the reactants, carbon and oxygen, come together to form a single product, which is carbon dioxide. On the other hand, decomposition reactions are basically the inverse or opposite of combination reactions. So in this, you start off with a complex compound which breaks down or decomposes to form simpler products. And this can be written as AB becomes A plus B. An example of a decomposition reaction is when water is broken down into hydrogen and oxygen. In this example, the complex compound is broken down to the basic elements. However, this is not always the case. For example, calcium carbonate can be broken down into calcium oxide and carbon dioxide. Here, the products are not basic elements like calcium, carbon, and oxygen. But because the calcium oxide and carbon dioxide are still less complex than their reactant, which is calcium carbonate, this is still an example of a decomposition reaction. Single displacement or replacement reactions are when a less reactive element is substituted for a more reactive one. So the element that starts off by itself replaces another one that is within a compound. And this can be written as A plus BC becomes B plus AC. For example, in the equation zinc plus hydrochloric acid, the zinc, which is the lone element, replaces hydrogen to form zinc chloride and hydrogen. So now the zinc is in the compound while the hydrogen atom is by itself. It's important to note that metals can only be replaced by other metals, while non-metals can only be replaced by other non-metals. In contrast, a double displacement or replacement reaction is when the metals of two reactants swap places to form two new products. And this can be written as AB plus CD becomes AD plus CB. An example of a double displacement reaction occurs when silver nitrate and sodium chloride combine to form silver chloride and sodium nitrate. The silver and sodium are both metals, so they swap places within this reaction. The fifth type of reaction, which is an acid-based or neutralization reaction, occurs when an acid combines with a base to form a salt and water. This is a special type of a double displacement reaction, and it is written as HA plus BOH becomes Ba plus H2O. Within this equation, HA is the acid, BOH is the base, and Ba is the salt that is created by the reaction. The final type of reaction, which is combustion, occurs when a fuel combines with oxygen to form carbon dioxide and water. It's important to note that every single fuel contains both carbon and hydrogen. And the general notation for this equation is fuel plus O2 becomes CO2 plus H2O. Examples of fuels include methane and propane. You may notice that all combustion reactions result in the same products. However, their reactant/fuel is always different. The reaction rate is the speed of the reaction, and this varies depending on the elements or substances involved. The rate of reaction is calculated by the change in product concentration divided by the time taken. And some factors that can affect reaction rate include 1. Temperature. Warmer temperatures mean faster reaction rate as the atoms can move more rapidly. Number 2, the surface area of solids. More surface area will increase the speed of the rate of reaction as more particles are exposed and there is more space for the reaction to occur. Number 3, the concentration of liquids. Higher concentrations mean faster reaction rates because more atoms are present and more interactions/collisions can happen. Number 4, the pressure of gases. Increasing the pressure increases the reactant particles within a given volume, therefore increasing the rate of reaction. And finally, number 5, the presence of a catalyst. A catalyst is a substance that speeds up the reaction rate by lowering the activation energy needed for a reaction. So to recap, a chemical reaction involves the atoms rearranging to form something new. And some physical indicators of chemical reactions include a change in color, a change in temperature, the production of a gas, the production of a solid or precipitate, and finally when sound or light is created. In my next video, I'm going to be talking about writing and balancing chemical equations, so make sure you stay tuned for that. If you guys enjoyed this video, make sure to like, comment, and subscribe to my channel for more. Thank you so much, and I'll see you guys next time. Bye!